Always, sometimes, never. Now we want to look at whether or not if we have two vectors and the dot product is 0, does that mean that at least one of the vectors has to be 0? In other words, if the dot product of x with y is 0, is it always, sometimes, or never true that x is 0 or y is 0? Well, let's look at some simple examples where perhaps x and y are of size 2. If we let x be, say, the vector of size 2 with components 1, -2, and y be the vector of size 2 with components 0, 0, and let's say another vector z to be the vector with components 2, 1, notice that if I look at the dot product of x with y, that's going to be 1 times 0 plus -2 times 0, which is 0. And in fact, if you have the dot product of any vector with the 0 vector, it will be true that that dot product will be 0. On the other hand, if I look at the dot product of x and z, that would be 1 times 2 plus -2 times 1, which is 0. But neither x nor z is actually the 0 vector. So it's sometimes the case that if the dot product is 0, that one of the vectors is 0. But unlike regular scalar multiplication, just because the product is 0 doesn't mean one of the factors is 0. So just because the dot product is 0 does not indicate that one of the vectors is the 0 vector. Only sometimes.